Good morning. Today we are going to look at the T formula, which is another technique that we use when we are integrating. Yeah. So this is the T formula. So we use this when we are integrating, and the way we do that is we make use of the substitution. We use tan of x over 2 is equal to t. Then to get the value of sine of x over 2 and the others, we draw a right angle triangle. So this is what our right angle triangle looks like. And we can put x over 2 here. And we know that tan is the opposite divided by the adjacent. So if I have t, that's t over 1. So my opposite is t and adjacent is 1. And then using Pythagoras theorem, we can work this out to be 1 plus t squared. Okay, so now that we have our triangle, we can then work out the value of sine x over 2. Sine x over 2, this is equal to the opposite divided by the hypotenuse, t over the square root of 1 plus t squared, and then cos of x over 2, this is equal to the adjacent divided by the hypotenuse. So this is 1 over the square root of 1 plus t squared. Okay, so now we have our sine, cos, and tan. We can work out what sine of x is equal to. So if we know sine x over 2, we know that sine x is equal to 2 times sine x over 2 multiplied by cos x over 2. This is the double angle identity that we know. So we can then substitute what sine x over 2 and cos x over 2 are, and then work out a formula for sine x. So this is 2 multiplied by t over the square root of 1 plus t squared multiplied by 1 over the square root of 1 plus t squared. And this is 2t over 1 plus t squared. And then also, we know that cos x, this is cos squared of x over 2 minus sine squared x over 2, again our double angle identity, and this is equal to cos of x over 2, we said is 1 over the square root of t squared plus 1, then we square it, then minus t over the square root of t squared plus 1, and then we square it. So this is 1 over t squared plus 1 plus t squared over a t squared plus 1, which just gives us 1 plus t squared over t squared plus 1. Sorry, 1 minus. This is a minus there, and that is a minus there. T squared plus 1, or you can just rewrite 1 minus t squared, 1 plus t squared, which might be easier to remember. Okay, so we have our cos and sine. Then we can also work out tan, which we know is sine x over cos x. This is equal to 2t over 1 minus t squared. Okay, so then these are the substitutions that we will use when working out integrals that look like this. So we will use these substitutions to work out integrals of the form of a sine x plus b cos x plus c divided by a sine x plus b cos x plus c dx. Okay, so here we have something like that. You have a fraction that you cannot break up using your double angle identities or the identities that we're doing this whole week, where you would have to rewrite it with a power and then you can break it down like that. So what we do is we know that t, or the t substitution, we say t is equal to tan x over 2. We can make x the subject of the formula. This means x is equal to 2 times tan inverse of t, and then we can work out dx and dt. So dx is equal to 2 times the derivative of tan inverse of t is just 1 over 1 plus t squared dt. And this means that dx is equal to 2 over 1 plus t squared dt. So we will substitute sine x, if it's there in the question, cos x in terms of t, this in terms of t, in terms of t, and then dx also, we write it in terms of dt. So this formula here, or this integral that we're given now, is now in terms of t, and what we get should be easier to integrate. And then after we've integrated it in terms of t, then we have to go back and substitute t in terms of x, because the question was in terms of x. We used the t substitution, so we need to leave our answer in terms of x again. So let's look at some of the examples. The first one, we have the integral of dx over 3 plus cos x. So here we just make the substitution. So dx, we said, is equal to 2 plus 2 over 1 plus t squared dt. So this is the integral of 2 over 1 plus t squared dt. And then the plus cos x, this is 1 minus t squared over 1 plus t squared. Okay, so we would then simplify this fraction, and then we expect that what we have after that will be much easier to integrate than what we started with. So this is the integral of 2 over 1 plus t squared dt. Then our denominator, we have 3 plus 3 t squared plus 1 minus t squared over 1 plus t squared, which is the integral of 2 over 1 plus t squared dt. Then in our denominator, we have 3t squared minus t squared, which is 2t squared plus 4. Is that right? 2t squared plus 4. and then divide this by 1 plus t squared. So we have these two fractions here dividing. Then you would change it to multiplication and then the reciprocal of the other. So what you are actually integrating is 2 over 2t squared plus 4 dt. Okay, so we can see that 2 is a common factor in the numerator and in the denominator. So we can cancel that out. Then we have the integral of 1 over t squared plus 1 plus 2 dt. Okay, so if we were to integrate this, we should already be thinking of tan inverse. The only thing is that this number here has to be a 1. So we factor out the 2. So this is the integral 1 over 2. And then we have t over the square root of 2 squared plus 1 dt. Then the half can go outside. So let me write it here. So we have a half, the integral of 1 over t over the square root of 2 squared plus 1. This is dt. And in order to integrate this, the derivative of t over the square root of 2 has to be in the numerator. So I need 1 over square root of 2 here. So on the outside, I will have 1 over the square root of 2, and then 1 over the square root of 2 in the numerator, and then t over the square root of 2 squared plus 1 dt. Okay, then make sure that when you multiply these two numbers here, you end up with half and redo. Okay, so now this is perfectly in the form to say it's tan inverse of something. So this is just 1 over the square root of 2, and then tan inverse of what we have inside our brackets here, which is t over the square root of 2, and then you add your constant of integration. Okay, so now that we've integrated it, you need to remember that in the question there was no t, so we need to write the t in terms of x and t. We said is tan of x over 2. So this is 1 over the square root of 2 tan inverse of 1 over the square root of 2 of tan x over 2, and then you add your constant of integration. We're integrating dx over 2 plus sine x. So again, make the same substitution. In terms of t, we know that dx, this is the integral of the integral of 2 over 1 plus t squared dt, and then 2 plus, and then instead of sine x, we write 2t over t squared plus 1, or 1 plus t squared. Okay, so we would combine the denominator the way we did the previous one and then divide the two fractions. Then what we end up with should be easier to integrate than what we started with. So this is the integral of 2 over 1 plus t squared divided by, combining these two fractions, we have 2t squared plus 2t, then plus 2t again. That will give us 2t, we said it's 2t squared plus 2 plus 2t. Okay, so this is 2t squared plus 2t plus 2 divided by t squared plus 1, or 1 plus t squared, and there's a dt over here. Okay, then okay, so we changed the division to multiplication and then the reciprocal of that one. So we have the integral of 2 over 2t squared plus 2t plus 2 dt. And then from there we can see that 2 is a common factor, so we can take that out. So this is the integral of 1 over t squared plus t plus 1 dt. Okay, so again, we want to end up with the tan inverse derivative. So what we need to do is we want to complete the square in the denominator. Okay, if it was possible, you could factorize and then try and use partial fractions, but here in the denominator you cannot factorize it and break it down in terms of its partial fractions. So the only thing to do is rewrite it when you have completed the square. And when you do that, we have dt in the numerator, and then we have t plus a half squared plus 3 over 4. Okay, then this is something squared plus 3 over 4, but we know that for tan inverse this has to be a 1, so we can factor out 3 over 4. So we have the integral dt here, and then we take 3 over 4 out, and what we have is 4 over 3 multiplied by t plus a half squared plus 1, like that. Okay, then this 3 over 4 is in the denominator, so when we take it out and write it here, this is, because it's in the denominator, it's 1 divided by 3 over 4, which is just 4 over 3. So on the outside we have 4 over 3, the integral of dt over, then this 4 over 3, we always want to include it so that it is part of the squared here. So doing that, we will have 2t over the square root of 3 plus 1 over the square root of 3 squared plus 1. Okay, then now it's in the, well, the denominator is in the form of something squared plus 1. We just need the numerator over here to be the derivative of what we are squaring here. And the derivative of what we are squaring here is 2 over the square root of 3. So in the numerator, I'll put 2 over the square root of 3 dt over 2t over the square root of 3 plus 1 over the square root of 3 squared plus 1. And then on the outside, I need to put a number here so that when I multiply it by 2 over the square root of 3, I still end up with 4 over 3. So I need to put 2 over the square root of 3 there. Okay, so now just a matter of integrating. So this is 2 over the square root of 3, and then we have tan inverse of 2t over the square root of 3 plus 1 over the square root of 3, and then we add our constant of integration. Then keep in mind that there was no t in the question originally, so what we need to do is rewrite t in terms of x. So this is 2 over the square root of 3 tan inverse, and then I can even 2 over the square root of 3, and my t we said is tan of x over 2, then you add 1 over square root of 3, and then your constant of integration. Right, so there's a bit of algebra that has to be done when solving this question, but the basic idea, if you remember and use the substitutions correctly, you shouldn't have any problems with working this out. And another one, number 3, we have the integral of dx over 1 plus sine x plus cos x. Again, t substitution rather. This is the integral dx, we said is 2 over 1 plus t squared dt, and then 1 plus sine x, that is 2t over 1 plus t squared, and cos, this is 1 minus t squared over 1 plus t squared. Okay, then this fraction here we need to simplify. So our denominator, or the first fraction, the one in the numerator, is just 1 plus t squared. Then I'll say divided by this one over here, we need to combine it. So we write this as a fraction. It's 1 over t squared, 1 plus t squared divided by 1 plus t squared. Then you add up all your you add up all your t squareds, your t's, and your constants that don't have a t. So you have 1 plus t squared plus 2t plus 1 minus t squared divided by 1 plus t squared dt. This is the integral. The division changes to multiplication, and we can see that the 1 plus t squared and this one will cancel. Same thing here with the t squared and the minus t squared, those will cancel. Then I will be left with 2 over, in the denominator I have 2t plus 2. Okay, and dt, and we can see that 2 is a common factor, so you can cancel that out. This is the integral of 1 over t plus 1 dt. Okay, this one very simple to integrate. This is just ln of t plus 1. So this is ln of t plus 1, then our constant of integration, and then again we need to remember that there was no t in the question, so we have to rewrite this in terms of x. So this is ln, and then instead of t, we have tan of x over 2 plus 1, and then you add your constant of integration. Then you should try the questions in the exercise 4.5. There's about 10 of them, but like I said, with this t substitution, it isn't that complicated because it's mainly just algebra that you have to do. If you make your substitution correct, or if you do your substitution correctly, then you shouldn't have any problems with it. So let's look at a few examples from exercise 4.5. Number 1, we have the integral of dx over 2 plus cos x. Okay, so with this one, again, just a matter of substituting directly. This is the integral of 2 over 1 plus t squared dt and 2 plus 1 minus t squared over 1 plus t squared. Then combining, this is 2 over 1 plus t squared divided by this fraction here becomes 2 plus 2t squared. So we have 2 plus 2t squared plus 1 minus t squared over 1 plus t squared. And when the division changes to multiplication and then we write the reciprocal of the other, you can see that the 1 plus t squared cancel. So in the numerator, I will have 2, and then in the denominator, I have t squared plus 3 dt. Okay, then again, here you should be thinking of tan inverse. The only thing is that this number here has to be a 1. So we factor out the 3. So this is the integral of 2 over 3, and then I have t over the square root of 3, the whole thing squared, and then plus 1 dt. So on the outside I have 2 over 3, the integral of dt over t over the square root of 3 squared plus 1. Then in the denominator, it is in the form that we want to use t inverse, but in the numerator here we need 1 over square root of 2, 1 over square root of 3. So this is 2 over square root of 3, integral 1 over the square root of 3, t over the square root of 3 squared plus 1 dt. So this gives us 2 over the square root of 3, and then the integral of this is tan inverse of t over the square root of 3 plus our constant of integration. Then again, remember there was no t in the question, so what we need to do is just rewrite t in terms of x. So we have 2 over the square root of 3 tan inverse of 1 over the square root of 3, and then tan of x over 2 plus our constant of integration.
Ma'am,
Yeah.
could you please go to the previous slide? Okay, thank you, ma'am.
Okay, number 2, we have the integral of cos x over 2 minus cos x dx. Okay, now with this question here, you can just substitute directly. Is that the one? But I think what you would get if you substituted immediately would be pretty complicated. What do we end up with here? And would be much longer than if instead of just substituting directly, you perform long division first. So here we have 2 minus write it like this, minus cos x plus 2, and then cos x, so we perform like long division. Then say minus cos x divided by cos x is minus 1. Then you multiply, you get minus cos x minus 2, and then you subtract. There's a 2 like that, then you subtract, and then you would sorry, this is positive because it's minus cos x times minus 1. Okay, then when you subtract, you get 0, and then negative, negative 2. This is positive 2. So our integral, which was cos x over 2 minus cos x, this is dx, cos x, this is actually just the integral of minus 1 plus 2 over 2 minus cos x dx, which would be easier to substitute than if I were to substitute in that. But even if you did it that way and you did your calculations correct, I think that your answer would still be fine. Okay, so integrating this part here, we have to use our u substitution, which is not very different from this one, except that here there was a plus and over there is a minus. So we have the integral of, well, let me just integrate the minus one, which is minus x plus the integral of 2 plus 2 minus cos x, we said is 1 minus t squared over 1 plus t squared, and then dx here, this is 2 over 1 plus t squared dt. Okay, so we would combine this numerator here, multiply this and that. You have 4 over 1 plus t squared. And then this denominator here, you would combine it and simplify as far as possible. So this is minus x. And we have plus the integral of 4 over 1 plus t squared. Then we divide this by, okay, if we look at our denominator, we have 2 minus t squared minus 1 plus t squared. So it's 2 plus 2t squared, 2 plus 2t squared, and then 1 minus 1 plus t squared, minus 1 plus t squared over 1 plus t squared, and there's a dt there. This is minus x plus the integral 4 over 1 plus t squared, and here we're just dividing by t squared plus t squared, 2t squared plus t squared is 3t squared, so 3t squared, and then 2 minus 1 is minus 1 over 1 plus t squared dt, which is minus x plus the integral of 4 over 3t squared minus 1 dt. Okay, so here our form, this is, we should be thinking of the hyperbolic tan inverse, because we have something squared minus 1. Okay, I see that I did wrong here. This should be plus, not minus. It's plus, because it's 2 minus 1, which is plus 1. Okay, so be careful with those things, because the difference between plus and minus means you get a different function when you integrate. Okay, so now that we have that, thinking tan inverse, and the only thing here is we need this 3 to be part of the square, and this number here on top must be the derivative of whatever it is we're squaring here. So this is minus x plus the integral of 4 over the square root of 3t, the whole thing squared, plus 1, and then dt here. Then our numerator, we have to make it square root of 3. So we have minus x plus the 4 will go out. We have to divide by square root of 3, so that we have square root of 3 here in the numerator. Then square root of 3t squared plus 1 dt. Okay, so now we can just integrate. This is minus x plus 4 over the square root of 3, and then the integral of square root of 3 over the square root of 3t squared plus 1. That is tan inverse of the square root of 3t plus our constant of integration. Then again, remember that there's no t in the question originally, so everything must be in terms of x. So you substitute t as tan x over 2. So our integral just becomes minus x plus 4 over the square root of 3. Then we have tan inverse square root of 3, and then tan x over 2, and our constant c over there. So I think we have time for one more. Let's look at number 3. Number 3. let's look at number 5 instead. Number 5. We have the integral of dx over 1 plus cos x plus sine x. Again, just direct substitution. The dx, we said that is 2 over 1 plus t squared dt, and then 1 plus cos x, this is 1 minus t squared, 1 plus t squared, and then sine x, this is 2t over 1 plus t squared. Okay, so what we're integrating is 2 over 1 plus t squared divided by, when we combine this fraction here, we have 1 plus t squared plus 1 minus t squared plus 2t. So we have 1 plus t squared plus 1 minus t squared plus 2t, and this is all divided by 1 plus t squared dt. The t squareds can cancel, then we have 2t plus 2. So this is the integral of 2 over 1 plus t squared divided by 2t plus 2 over 1 plus t squared dt. And this is the integral of 2 over 2t plus 2 dt. And we can see again that 2 is a common factor, so we can just cancel that out. And then we are left with the integral of 1 over 1 plus t dt, which is ln of 1 plus t plus c, and then rewrite t in terms of x. So this is ln of 1 plus tan of x over 2 and our constant of integration. Then number 10, this one says we must integrate sec x using the t formula. We've integrated this several times already, and we know the derivative is ln of sec x plus tan x, but we can also use the t formula over here because this is just the integral of 1 over cos x dx, and then we substitute dx and cos x. This is the integral. Dx, we said, is 2, right, like that, 2 over 1 plus t squared, and then we divide by cos x, which is 1 minus t squared over 1 plus t squared dt. This gives us 2 over 1 minus t squared dt. Okay, so now the 2 can go outside. So this is 2, the integral of 1 over 1 minus t squared dt. And then this one here, we just integrate as the hyperbolic tan. So this is 2, the hyperbolic tan inverse of t, and our constant of integration, and then we substitute t. So this is 2, the hyperbolic tan inverse of tan of x over 2, and then you add your constant of integration. So you can see that with functions, there isn't always just one way that we integrate them. like this sec x, usually we would say it's ln of sec x plus tan x, but this is also its derivative. Okay, so that is it on the T formula. Try the other questions in the exercise. So remember what I always say, you need to constantly practice. The test is next week Friday, so we don't have too much to cover after this. So we're almost done with integration. But the thing with integration is that there are so many techniques, and waiting until the last minute to try and learn all of them, practice all of them, you will not be able to do that. Okay, so we'll stop here for today and then we'll meet on Monday.